Autonomic nervous system question answer explanation. Now this part is related to more of drugs. The previous part I have discussed about physiological questions. Now this part is related to pharmacology as well as medicinal chemistry part. Now let us look at the questions. Now, which of the following beta blockers contain a heterocycle? See, this is related to medicinal chemistry question. Now let us see the answers. Propranolol, nadolol, timolol, etenolol. All of them are beta blockers. But what you need to understand is, see, propranolol contains naphthalene ring. Is naphthalene a heterocycle? No, this is a carbocycle. Carbocycle means the cycle is made up of only carbons. Similarly, nadolol is also a derivative of naphthalene ring. Again, there is a carbocycle. Timolol. Now, timolol is different. See, I explained in the class already. Timolol, the name itself will give you certain hints about the structure. See, timolol indicates it has got thiadiazole ring and morpholine ring is there. That's why it has got timolol is derived like that. So timolol contains two of the heterocycles. So the drug which contains heterocycle is timolol. Now etenolol is again a simple phenyl derivative. So again it has got a carbocycle, not a heterocycle. So answer C is correct. So this is related to medicinal chemistry. Now understand this, for any competitive test, they are not going to check the entire structure. You need to identify what is the heterocycle in the structure or what are the important functional groups. Now all these drugs are aryl oxy propanol amine derivatives. Aryl oxy propanol amine derivatives. Now this is what is called as pharmacophore. Pharmacophore means the group or a ring which is essential for the mechanism of action of the drug. All of them contains aryl oxy propanol amine derivatives. So you need to have this thing. Now let me draw this thing. See, aryl, any aromatic ring, oxy, propanol, 3 carbon containing. In fact, it is 2 propanol, amine, this one. So this is what is the general structure of all these beta blockers. Aryl oxy propanol amines. Now in that heterocycle is timolol one. So option C is the right answer. Going to the next one. Now which among the following cholinergic exhibit highest acetylcholinesterase resistance? Understand this word. Acetylcholinesterase resistance. Resistance means it is not easily being metabolized by acetylcholinesterase. Now acetylcholine duration of action is very short. That is the reason why we cannot use it. If you see the structure of acetylcholine, see, choline part is this. CH2. Choline is an alcohol. These alcohols combines with ester and forms acetylcholine. So this part is acetyl part and the remaining part is choline. An alcohol and acid combination gives acetylcholine. The problem comes here. So this is what is an ester linkage. This ester linkage is easily cleaved by enzyme like acetylcholine esterase. So the duration of action of acetylcholine is very short. Let us leave the option B. Let us see the remaining things. Now, there is a modification of acetylcholine which is known as methacholine. In case of methacholine, this carbon has got a methyl substitution. Now, what is the significance of methyl substitution? When methyl substitution is there, due to its base, it causes steric hindrance. For what? For this enzyme. This enzyme has to come like this and break this bond, and this methyl group is causing steric hindrance. So methacholine duration of action is little bit more than acetylcholine. So it is more resistant than acetylcholine. But the question is about which among the following exhibits highest resistance. Let us see the other one. Carbachol. Carbachol is a different drug. In carbachol, this amide is changed. This amide, this ester is changed to this group, carbamate group. Now what happens is, because of this electronic distribution, again the metabolism by acetylcholinesterase is reduced. This is because of electronic parameters. Now understand this. What happens is, I'll just draw this part. See, the problem comes with ester breakdown. Now what happens is, nitrogen with its lone pair of electron, it donates electrons like this. These electrons will move like this, and oxygen electrons will come like this. So what has happened? All this has become a partial double bond. So metabolism by acetylcholinesterase is a little bit hindered. So the resistance is even more than methacholine. Now, when you see bethanechol is a combination of both the things. Bethanechol will show both the transformations. This, see, you're not doing any change at this end. The change occurs only here. So bethanechol contains this modification, electronic modification, as well as on this, see, a methyl substitution is there. So two ways the enzyme is blocked. That's the reason why the highest resistance is shown by bethanechol. Again, this is related to structure-activity relationship question. Again, understand the differences. You need to read SAR like this. Understand how the groups are changing the activity. By attaching a methyl group, steric hindrance is increased, metabolism is reduced. By changing an ester to amide, again, electronic parameters are changed, resistance is reduced. When you incorporate both the changes, highest resistance be there, and option B is correct. Let us go to the next question. See, which of the following pairs shows isosteric replacement? Again, this is also a concept-oriented question. Now, let us understand this one. See, albuterol, pyrbuterol. Now, what is the difference between albuterol and pyrbuterol? I'm not drawing the entire structure. I'll draw what are the groups responsible for that isosteric replacement. Now, look at these two structures. What is the difference? The difference comes only at this junction. What has happened? In place of a carbon CH, a nitrogen is substituted. Now let us understand. Let us see the valency numbers of these things. Now, what is the valency of carbon? It is 4. What is the valency of hydrogen? It is 1. Now 4 plus 1 equal to 5. What is the valency of nitrogen? 5. So this is what is there. If you substitute a group of atoms with an atom which has got similar valence electrons, that is called isosteric replacement. So in first question, albuterol and pyrbuterol shows isosteric replacement, and both of them show the actions. Now let us see the next one. Procaine amide, procaine. Understand this procaine amide and procaine. Procaine amide and procaine. See, procaine amide is CONH, whereas procaine is an ester derivative, COO. Now, oxygen is substituted with NH. What is the valence of oxygen? Oxygen 6. Now nitrogen NH. Nitrogen is 5 plus hydrogen is 1. Totally how much? It is 6. Both of them are same. So procainamide and procaine is also example for isosteric replacement. Now we have amino acids serine and cysteine. Now serine and cysteine, the difference is serine is a hydroxy derivative, cysteine is mercapto derivative. Oxygen, sulfur, both of them belong to same group, 6. So this is isosteric replacement. So again, this is also an example for isosteric replacement. So all the three pairs show isosteric replacement, hence the option D is the correct answer. So at the max in medicinal chemistry, you will expect this kind of questions. Either they will check for heterocyclic ring, or they will test your knowledge in structure activity relationship, or on concepts like isosteric replacement. Okay, let us move to the next one. Now, alkylating adrenolytic drug. Now, see, the word alkylating comes from alkylating agents. We have alkylating agents as anti-cancer agents. The uniqueness with alkylating agent is they contain a bis chloroethyl groups. This group will be present in all alkylating agents. You take cyclophosphamide, melphalan, cyclophosphamide, all of them contains this group. Now, what is the uniqueness of this group is, see, this chloride is a very good leaving group. It leaves as Cl minus. So it leaves CH2 with a cation, carbocation. Now this cation will try to go and attack wherever it finds electrons. Usually the highest amount of electrons are there with nitrogen. And nitrogen, see, this is how a bond forms. Carbon with positive charge acts as an electrophile. Phile means love, electro means negative charge. It goes toward this one and forms a bond like this. So what has happened to this nitrogen? It is attached with CH2, which is an alkyl group, and this is what is called as alkylation. Now, the question is which one has got adrenolytic drug which is alkylating? Adrenolytic. Lytic means antagonist or blocker. Phenoxybenzamine. Phenoxybenzamine is non-selective, irreversible, and non-selective alpha blocker. Now, phenoxybenzamine contains this side chain. So it also acts as alkylation. It causes alkylation of alpha receptor. So the answer for alkylating adrenolytic drug is phenoxybenzamine. Again, this is related to structure 1. I told you already, you need to remember either a heterocycle or important functional groups like this. This is enough. You don't need to break your heads over the medicinal chemistry drug structures. Structure, complete learning is not required. This thing is enough. Now, phentolamine is also non-selective blocker, but it will not cause alkylation. Propranolol is a beta blocker. Prazosin is a selective alpha-1 blocker. Again, all of them, they are not alkylating. Only phenoxybenzamine is alkylating. Okay? Okay, let's move on to the next question. Drug that acts as neurotransmitter in CNS and exhibits cardiotonic effects on periphery. Understand this one. See, a drug which is acting as neurotransmitter in CNS but has got cardiotonic effects on the periphery. Now look at the dopamine. Dopamine is a neurotransmitter in CNS. For many neurons, it is the best example is nigrostriatal pathway. Nigrostriatal pathway. There, the neurotransmitter is dopamine. In Parkinson's disease, this dopamine levels decreases. To increase this, we use levodopa. Levodopa gets into the brain, converted as dopamine, and acts as neurotransmitter here and treats the condition. So in CNS, it acts as a neurotransmitter. That's why it is used to treat Parkinson's disease. Cardiotonic effect on periphery. See, dopamine is a very good beta-1 agonist. Dopamine and dobutamine, both of them are beta-1 agonists. So the question is asking about dopamine. The right answer is dopamine. Now see, epinephrine, dobutamine, serotonin, no. See, epinephrine will not get into the CNS. It is only a hormone which is released from adrenal gland. Dobutamine is a synthetic drug which acts only at periphery. Serotonin or 5-hydroxytryptamine acts in the brain, but it will not act. It will not show any cardiotonic activities. So the option A, dopamine, is the correct answer. Okay. Now let us move on to the next question. Alpha-2 agonist used in glaucoma is guanafacine, guanabens, brimonidine, tizanidine. Options are given. Now see, guanafacine, guanabens, both of them acts at ganglion. So they are not used to treat glaucoma. Brimonidine is the drug of choice to treat glaucoma. Whereas tizanidine is used as a central skeletal muscle blocker. Central skeletal muscle blocker. So tizanidine is widely used to treat pains. Tizanidine is available as 2 mg drug, 2 mg tablet. It is very powerful acting to alleviate the pain. So here the alpha-2 agonist used to treat glaucoma is brimonidine. Apraclonidine, brimonidine are choice of drug to treat glaucoma. Glaucoma is a condition wherein intraocular pressure is increased. To reduce that, these drugs are used. So option C is answer here. The next one. Now, nicotinic receptor sites include all of the following except. Nicotinic receptor sites include all of the following except. Let us see the options. Bronchial smooth muscle. On the bronchial smooth muscle, we find beta-2 receptors, but not nicotinic receptors. So the question asks, nicotinic receptor sites include all of the following except. So here you don't find nicotinic receptors. Now adrenal medulla, yes, you have nicotinic receptors on the adrenal medulla. Skeletal medulla, we have already seen. On skeletal medulla, you have nicotinic receptors are there. Sympathetic ganglia, all the three contains nicotinic receptors except bronchial smooth muscle. So option A is correct one. Next one. Sweating as a result of exertion is mediated through. Now see, again, this is a unique question. Adrenal hormones? No. Sympathetic adrenergic? No. Parasympathetic cholinergic? No. Sympathetic cholinergic. Now, this is the right answer. Understand the question. See, sympathetic adrenergic means sympathetic neurons which are releasing noradrenaline as a neurotransmitter is known as sympathetic adrenergics. Sympathetic cholinergic means sympathetic neurons at the postganglionic neuron which release acetylcholine are known as sympathetic cholinergic. These neurons only you will find with sweat glands and pilomotor erector muscles. Now the question is about sweat glands. So this is by sympathetic cholinergic. So option D is correct one. Understand this properly. You have only one exception wherein a sympathetic neuron releasing acetylcholine as a neurotransmitter. That is called as sympathetic cholinergic and it is there with sweat glands. So option D is the right answer. The next one, all are cholinergic actions except. Now be careful with except questions. The clause comes at the end. Okay, except. Now look at the options. Bronchoconstriction, yes, it is a cholinergic response. Salivation, yes. Meiosis, pinpoint pupils, yes. Tachycardia means increase in heart rate, no. Cholinergic actions are bradycardia, decreased heart rate. You know, when we are about to sleep, when we are in a sleep state, heart rate is reduced. It is around 60 beats per minute. It is because of cholinergic stimulation. So except means it causes decrease in heart rate, but here it says increase in heart rate. So except means this is what is the answer. For ninth question, option B is the right answer. Okay, let's move on to the next one. Now, all of the following drugs are used for the treatment of urinary incontinence except. Give me a second. Now, see, to treat urinary incontinence, antimuscarinics are used. Antimuscarinics are used. Like oxybutynin, dorphinacin, sulfinacin, tolterodone, fesoterodone, all of them are used. Only exception is ipratropium. Now, ipratropium, tiotropium, these two drugs are used to treat chronic obstructive pulmonary disorder. What they do is they reduce the bronchial secretions, so the pulmonary obstruction will get relieved. So this is used for specifically to treat COPD. But the question is asking about urinary incontinence, except. Exception is this one. Oxybutynin, sulfinacin, tolfinacin, all of them. They are used to treat urinary incontinence, but ipratropium, tiotropium is used to treat chronic obstructive pulmonary disorder. So option B is right answer here. Now the next one. Drug of choice for mushroom poisoning. Now understand this one. Mushroom contains chemicals like muscimol and muscarine. These have direct actions on muscarinic receptors, M1, M2, M3, M4, M5, all of them. So it shows very highest cholinergic actions. So in mushroom poisoning, you will see all muscarinic actions. So this can be blocked by cholinolytic agent. The cholinolytic agent is atropine. Now physostigmine is again cholinomimetic. This should never be used. Adrenaline is unrelated drug. It acts on sympathetic system. Carbachol is again a synthetic derivative of acetylcholine. This should not be used. So the problem comes from hyperactivation of muscarinic receptors, and that can be blocked by muscarinic blocker, and that is atropine. So option A is right answer. Now the next one. Atropine poisoning causes all except. Now let us understand this. Dilated pupils. Yes, it causes dilation of pupils. See, atropine action is opposite to muscarinic action. Muscarinic actions causes meiosis. So the opposite action is dilation of pupils. So this is true, right? Excitement. Yes, atropine also causes a kind of delirium condition. Yes, this is also true. Now, excessive salivation. Now look at this. Excessive salivation is a response of acetylcholine. The response is SLUTD. The first one is salivation. Atropine blocks salivation. In fact, it causes dry mouth, xerostomia. So this is not, again, this is except question. This is not. Now hard skin, the reason why it is called is the secretions like sweating is reduced because of atropine blockade. So hard skin is also a response of atropine. So only the exception is excessive salivation. This is not. This is caused by cholinergic stimulation. So this is the second set of ANS questions. Okay. So any doubts in this set? Sorry. You want me to repeat any of the questions? Eighth question. Question number 8. Okay, let me check. Okay, question number 8. Sweating as a result of excretion is mediated through. Yeah, see, okay, understand this one. See, the question asks about sweating as a result of excretion is mediated through. See, sweating is mediated through the neurotransmitter acetylcholine, but the neuron is considered as sympathetic neuron, not parasympathetic system. It is considered as sympathetic system only. I told you in the class, when you see this thing, when you see autonomic nervous system, the classification is based on anatomy, not because of neurotransmitter. What is the anatomy here? You take for the example of a sympathetic nervous system, you have a short presympathetic neurons are there and long postsynaptic neurons are there. Whereas in case of parasympathetic system, you have a long postsynaptic neuron and long presynaptic neuron and short postsynaptic neuron is there. Now, sweat gland innervation is related to this one. So that is the reason why, because I'm sorry, wait a minute. Sweat gland innervation is because of this system. That means sympathetic neuron system. So though the neurotransmitter released is acetylcholine, anatomy wise it has got a short preganglionic neuron and long postganglionic neuron. It is considered as sympathetic cholinergic. So the classification, how whether sympathetic or parasympathetic is classified is based on anatomy, not based on neurotransmitter release. So that is the reason why it is releasing acetylcholine, but because anatomy wise it has got a short preganglionic and long postganglionic, the neuron which is going to sweat glands, it is considered as sympathetic cholinergic. So this is mediated through sympathetic cholinergic. So option D is correct here. Yeah. Any other doubts are there? Okay. Then let's move on to the next part.
Unacademy. Let's crack it.